Okay, this is geometry. We'll begin 11.3, finding the area of polygons. I'm going to review some formulas with you to find the area of polygons. So we'll go through this first part kind of quick. One type of polygon that you really should know how to calculate the area for is for a triangle. So if I have a triangle and I'm not going to use trig, we need to know two things, the base and then the height. The height's going to go from one vertex and it's perpendicular to one of the sides. So the formula for the area is the area equals, most of you know it as base times height divided by 2, but it's also the same as 1/2 base times height. And then the second polygon that we could find the area for is a rectangle. So if you recall when we were studying quadrilaterals, you have to have opposite congruent sides and all right angles. So to calculate the area of a rectangle, if you let one of the sides be the base and then a perpendicular side be the height, then the area of that rectangle is just the base times the height. For a parallelogram, opposite sides are parallel. You can let one of the sides be the base, and then the height would be the distance from one of the bases to the other base. So this would be the height. It has to be perpendicular actually to each of the bases. Then the area formula is the same as for a rectangle, base times the height. Okay. Another polygon is a square where all sides are congruent and all the angles are right angles. If you let one of the side lengths just be s, then the area of the square is s times s, or s squared. Those are all review, and then we can go over some examples of those a little bit later. A couple of new formulas that we haven't covered yet are for finding the area of a rhombus that's not a rectangle, so in other words, then it would not be a square, and a kite. For a rhombus, you have to remember that all sides are congruent. Opposite sides would be parallel as well. But for a rhombus, the formula for the area of a rhombus, you have to know each of the diagonals. So I'm going to let one of these diagonals be diagonal 1 or d sub 1. The subscript just means diagonal 1. And then the other diagonal, which is what I drew here, let that be diagonal 2. And then the area of a rhombus is the diagonals multiplied together. Diagonal 1 times the diagonal 2, and then you divide that by 2. For a kite, the formula is actually the same, but it's a different polygon. You have to remember a kite's a quadrilateral where two pairs of consecutive sides are congruent, but similar to a rhombus, you have a diagonal. So this is one of the diagonals. This could be diagonal 1. It could also be diagonal 2. And then if this diagonal is diagonal 1, the vertical diagonal, then this other diagonal is diagonal 2. Again, it's the exact same formula. Diagonal 1 multiplied by diagonal 2 divided by 2. Or you can also write either of these formulas, diagonal 1 times diagonal 2 multiplied by 1/2. It would be the exact same thing. So just taking a look at a couple of examples on finding the area of either a kite or a rhombus. So on number 1, this is a rhombus. All the sides are congruent. One of the diagonals is 14 units in length. So I'm going to let that be diagonal 1 because you just have the 7 and 7. The other diagonal is 20 units in length. I'm going to let that be diagonal 2. Then in order to calculate the area, diagonal 1, 14, multiplied by diagonal 2, 20, and then you want to divide that by 2. So you can multiply 14 by 20, it's 280, divided by 2. So then the area of the rhombus would be 140 or 140 square units. In this case, it's actually 140 square inches. Then for example 2, pretty much the same thing. One of the diagonals, which is what I'm going to let diagonal 1 be, is 5 plus 3 or 8 centimeters. The other diagonal, the vertical diagonal, 2 plus 2, so that's 4 centimeters. Then the area is diagonal 1, 8, times diagonal 2, 4, and then divide that by 2. So the area 8 times 4, 32, divided by 2, area is 16 square units, in this case 16 square centimeters.